Hello guys, I'm starting a new series to learn the OpenMC. So in this video I'm going to start with the introduction and how does OpenMC works and what are the inputs we can provide to the OpenMC and what are the outputs we'll get from the OpenMC and why is this OpenMC special and how can we run it, what are the basic things we need to know and what is its application. So OpenMC is a code where it helps us to simulate a neutral particles like neutrons and photons to interact with themselves and interact with the matter, and it gives us a solution for the overall system. And it was originally developed by computational reactor physics group at MIT. And first question is like why we need this OpenMC code. And uh, for example, where we deal with the neutrons and photons is like neutrons in the nuclear fusion or nuclear fusion reactors, where it is we can to change some parameter and check it out the outcomes. It is very expensive, first of all, to change the material and instruments, and it is very unsafe to while we dealing with the radioactive material. So these simulations helps us to like get the outcome and check out the what is the outcome after the change in the parameters, and after getting the result we can implement that in the experiment. And the parameters which we can change, for example, are like density of the fuel and what temperature we are dealing in the geometry and what are the different materials we can use in the reactor. And OpenMC works on Monte Carlo method. Means for example, there are two methods we use to get the solution. One is deterministic method and other one is a Monte Carlo method. Where in deterministic method we are giving initial input where we know the values, and it will give us the outcome at the end of the outcome in the after the system. So in the deterministic method, it is easy to work with the simple problems, but it is very difficult while working with the complex problems. And in deterministic method, it takes less time and it is less computationally heavy. And in Monte Carlo method, where we don't need to give the initial inputs, it starts with the random samples, and at the end of the problem, like end of the system, like after interacting with particles, it gives us the average solution of the whole system. So it helps us to get the solution for the complex problems. That is the difference between the Monte Carlo method and the deterministic method. Where OpenMC work with the Monte Carlo method, it helps us to solve the complex problems. And it start with the like small one particle neutrons, then it start to interact with other particles and it produces millions of the particles. And at the end of the system, like we'll get the solution of the average solution of the whole system. And what are the inputs we can give to the OpenMC? We can give them what kind of geometry we want and what kind of materials we want to use, at what temperature you want to do this, and what is the source of the particles and other settings. And some of the outputs we'll get from the OpenMC are like K effective number, means it helps us to get to know the chain reaction is happening from the previous one. Is it increasing or the decreasing? If it is the same as a previous chain reaction, it gives us 1. If it is more than it is increasing, then it gives us more than 1. If its reaction is decreasing, it gives us less than 1. It also gives us the space and energy of the particles in the system and power distribution, which is like heat distribution in the system, and it gives all the results with the uncertainty. So we get to know how sure about our solution in the system. And what is the special about OpenMC is like it is built for especially simulation efficiency, and it is easy to use like Python interface, and we can import a lot of quality physics data which is like accurate data to use for this solution simulation. And it has advanced features like multi-group method, fuel burn-up, and acceleration techniques. These are the advanced methods. We'll get to know these methods as we go along. And to start with OpenMC, it is better to have comfortable working in the command line environment and basic proficiency in Python and familiar with the Git, because OpenMC uses Git for the tracking the code changes and the document changes. So it is helpful to if you know these basics. If you don't know, it's fine. We'll learn along the way. And to install OpenMC, we need a minimum like 8 GB RAM, where we can run the small simulations. As the problem become complex and it's become computation heavy, as we need to increase the RAM. But in the starting to learn, we can use small simulations, and we can use OpenMC easily. And we have to import nuclear data libraries to create the simulations. And I will talk about this more in the next video. And now we'll talk about the application of this OpenMC, where we can use this for the reactor design of the fission and the safety and medical studying, because of many scans, MRI scans, other spectra of electric spectra rays scans, and other space missions, like where there is a interaction between the photons and the neutrons themselves with and other materials. And we can also use this for the research. Yeah, that's all for this today, and thank you for watching. I am following the OpenMC guide to learn these things. So if you want more detailed information, you can go through that. I put the link in the description. Thank you.